All right, let's take a look at this Bayes' theorem problem using a table. So we're given that the probability of A is equal to 0.61. So let's make this table. Let's put the totals here and here. And let's start off with the first column being the column for A. And they told me that the total probability or the marginal probability of A is 0.61. So that means that A's complement, which I'm going to put in the next column, is the complement, so the probability has to be 0.39 or 1 minus 0.61 because these have to add up to 1. They do have to add up to 1. Okay, now they also tell me that given A, the probability of B is 0.12. So the probability of B given A is 0.12, which means if I already know I'm in this column, the probability of B happening, given that I'm in the A column, is 0.12, but that's 12% or 0.12 of the 61%. So that is actually going to be the probability of A and B. So the probability of A and B is going to be the probability of A, which we're given as 0.61, times the probability of B given A, which is 0.12, which is where I'm getting 0.61 times 0.12 for the joint probability that goes here. And that's how I'm going to get the other joint probability also. So that first one is going to be 0.0732 because it's 0.61 times 0.12. In the same fashion, I can go through and I can find the joint probability of B and A's complement because I know the probability of B given A's complement. 75% of this 39% is going to be B given A's complement. So what I need to put here is 0.75 times 0.39. 0.75 times 0.39 is 0.2925. So I took the probability of A's complement and multiplied it by the probability of B given A's complement to get the joint probability of B and A's complement. All right, now it turns out that if I want the probability of B, I can just add the probability of B and A to the probability of B and A's complement, and then the total probability of B is just the sum of those, which is 0.3657. 0.3657. Now, I'm left with this middle row to calculate. And that's actually not too bad because this is the total probability of A. This is the probability of A and B. So if I add to that the probability of A and B's complement, it should equal 0.61. So what I'm saying is, if I want to find this missing cell, I can just take the total and subtract the probability of A and B. So that's going to be 0.61 minus 0.0732, which is 0.5368. The last, or this next one, this one here, is going to be the 0.39 minus the 0.2925, which is 0.0975. And lastly, I can either add these two up to get this, or I can subtract 0.3657 from 1. Either way, we'll get 0.6343. So there I have all my joint probabilities in the middle and all my marginals on the edge. So I can go through and I can find what they're asking for. They're asking me for the probability of A given B. Well, that means I already know that I'm in the row that has B in it. So I know I'm dealing with this 36.57%. But I want to know what's the probability of A given B, which is going to be the probability of A and B, which is that 0.0732, divided by the probability of B, the marginal probability, 0.3657. So that's going to be 0.0732 divided by 0.3657, which is 0.0 or 0.2002. 0.2002. And that is the answer. So the probability of A given B is equal to 0.2002.